Now moving to another type of hybridization between the s and p orbitals. In this type, the s orbital hybridizes with only 2 p orbitals. That is why it is called sp2 hybridized orbitals. The number here refers to the number of the p orbitals involved in the hybridization. The result of the hybridization is the 3 hybridized sp2 orbitals. Notice this leaves one p orbital unhybridized. This is the orbital that usually forms the pi-covalent bond. Here we have the carbon sp2 hybridized. You can see the hybridization results in the formation of the 3 sp2 orbitals with 1 electron each and one 2p orbital that has 1 electron. The 3 sp2 orbitals lie on the same plane with angles equal to 120 between the 3 hybridized orbitals, and the unhybridized p orbital lies on a plane perpendicular to them, which makes the angle between the unhybridized p orbital and any of the 3 hybridized orbitals equal to 90 degrees. So we have one s orbital hybridized with 2 p orbitals with a ratio of 1 to 2. This is why the formed sp2 orbitals have 33% s character and 67% p character. Let's look at ethylene molecule. It has 2 carbon atoms that are sp2 hybridized. The 2 carbons form 4 sigma bonds with 4 1s hydrogen atoms due to the overlap of the 4 of the sp2 orbitals of the 2 carbon atoms and 4 of the 1s hydrogen orbitals. The 2 remaining sp2 orbitals of the 2 carbon atoms overlap, forming the carbon-carbon sigma bond, and the 2 unhybridized 2p orbitals of the 2 carbons overlap to form the carbon-carbon pi bond. By that we have a total of 6 bonds. Oxygen and the nitrogen atoms also undergo the sp2 hybridization. Oxygen 2 lone pairs reside in the hybridized orbitals, where one of the sp2 orbitals and the 2p orbital are occupied with 1 electron each. Also, the nitrogen sp2 hybridization results in the formation of the 3 sp2 orbitals, and one of the 2p orbitals remains unhybridized. The nitrogen lone pair resides in one of the hybridized sp2 orbitals as well, leaving the 3 remaining valence electrons singly occupying the sp2 orbitals and the unhybridized 2p orbital. Let's go back to the compound trihydroboron. We talked that this compound doesn't obey the octet rule, and there are only 6 electrons around the central boron atom. And the VS EPR told us that the trihydroboron molecule has trigonal planar geometry. The hydrogen-boron hydrogen angle is equal to 120, which means it undergoes sp2 hybridization. First, the boron atom undergoes the sp2 hybridization, where the 2s orbital hybridized with 2 of the 2p orbitals, and the result is the formation of the 3 sp2 orbitals. Each contains 1 single electron, and the unhybridized 2p orbital remains empty. The 3 sp2 orbitals of boron overlap with the 3 hydrogen atoms 1s orbitals, forming the 3 boron hydrogen sigma bonds. Remember, we said the sp2 orbitals all lie in the same plane, and the angle between them is 120, where the 2p is perpendicular to the 3 sp2 orbitals and remains empty.